Hello everyone, and my today's talk is called Not Your Father's ReSharper. So we've got a lot to cover. So without further ado, let's start. So in case you missed it, ReSharper just turned 20 years, and our web team has put together an amazing timeline, which you can check out by following the link on the slide. If you haven't already, I highly recommend visiting it. But instead of repeating the timeline, I want to present ReSharper from a couple different perspectives. Starting with the product perspective. It may come as a surprise, but from the very beginning, not one but two projects were initiated: a Visual Studio extension and a .NET IDE. Although I couldn't find screenshots of ReSharper V1, the image on this slide shows a later version from 2005. Even then, ReSharper was remarkably capable, featuring navigation, code completion, live take templates, code highlighting, and of course, rename refactoring. And it was quite an improvement of the default Visual Studio experience. As for the full-fledged standalone ReSharper IDE, plans to release it were shelved, I'd say, but the developed shell was later reused for other products. And let me show you something. So, yeah, here is ReSharper ID. Yeah, so that's what preceded writer. So you can see that I have some basic code highlighting. I have code completion. Yeah, I have. I can even. I can rename stuff. Let's rename to Great Britain. Right. Of course, I can find usages. And if I go here, where is it? Tools, options. So you can see that we had, even back then, lots of different formatting, code style options. We had some options for Visual Basic as well. And yeah, we only had that much code inspections. Yeah. Also, we had unit tests, which is also very important. Yeah, but let me jump back to the presentation. Okay. So fast forward to today, ReSharper is the most popular extension for Visual Studio. Over the years, it has transformed how developers explore, write, improve, and maintain their code. In fact, it has inspired other developer tools and IDEs, including Visual Studio itself, to improve. At conferences, I like to ask people why they choose ReSharper over vanilla Visual Studio. In summary, ReSharper offers unmatched experience. It's not just about the number of features. It's the feeling of always being supported with relevant suggestions, helpful code fixes, and powerful refactorings. The other camp, those who prefer Visual Studio alone, usually they mention performance issues with ReSharper. And I personally remember some lags when working with Visual Studio 2015. However, since then, both Visual Studio and ReSharper have made significant performance improvements. And most importantly, Visual Studio 2022 is now a 64-bit application. For years, we were sharing the same 32-bit memory space, which of course, led to many out-of-memory exceptions and frequent garbage collection pauses. Now, that's no longer an issue. And I've experienced exactly 0 crashes due to running out of memory. If you stopped using ReSharper because of performance concerns, I think now would be a great time to give it another try. And continuing the topic of performance, I can't resist in telling you about Acing Typing, which was released in 2024.2. So this feature is part of our ongoing effort to run ReSharper out of process, though it doesn't involve a separate process just yet. Instead, it uploads some typing-related operations, typing handling, from the UI thread to a background thread with subsequent merging of changes from different threads in a consistent way. While this may sound easy, it's actually an incredibly complex task. And kudos to Alexander Ulitin, who pulled it off. And as you can see on this slide, he even built a device to measure typing latency. How cool. The plots on this slide show that the last version delivers faster and more consistent typing responses. The large spike at 15-20 milliseconds, the last release indicates that users will most frequently experience very low latencies. And there's more. In fact, every release includes a bunch of performance improvements. Nikita Popov and Ilya Usov made important changes to the component container, improving startup performance. Alexander Shvedov implemented a high resource utilization mode for solution-wide analysis, which significantly reduces the time needed for initial processing. Andrei Dyatlov sped up the move to another type refactoring and also fixed incrementality of code analysis engine on large files. And as for me, I've been working on making find usages, rename refactoring, and most recently, just a couple of weeks ago, code cleanup run faster. I can't emphasize enough how important it is for us to improve performance. And it really warms our hearts when we read your comments on fixed issue tickets. Of course, there's still a lot of work ahead, but we are committed to continuing this effort. Now, let me do the quick ReSharper demo. So let me switch to Visual Studio. So QA told me that they found some wrong behavior of this code cleanup feature. And I decided to investigate it and ultimately pinpointed to this method. So what we see here, so I open this file and I immediately see this to-do comment. But what you can also see that ReSharper is very helpful in not only code highlighting, but it also highlights the grammar error, and not just highlights, but it gives me the fix as well. Yeah, so generated files should be excluded. So let's try to implement it. So I go to source file, properties, the generated file, and I use this postfix template not and if, and I'd like to exclude it from this files list. ReSharper highlights the remove method. And what's going on? Yeah, so it tells me that system invalid operation exception um, is possible because the collection was modified. So how is that? So I'm modifying collection while iterating over it. Yeah. So that's the problem. So what I would do instead, so I would create another collection and to use postfix template again. I will call it filtered files. And so what I would do is, so I'm using this structural navigation feature to replace parts that I need. I'm going to replace remove with add. And you can see that filtered files collection is updated but not used. Yeah, because I need to update the usage as well. Yeah. So let's take a look what's going on below and down here. So here I have this input and output. So input is my filtered files and output is tuple of source file and hash set of type. And then I define some scope of work, create a test barrier, and then spin up many threads, which basically take files from this input, then run code analysis, and then select from highlighting they found their types. Okay. But we can see here that ReSharper highlights this task barrier variable. And if I hover it, it tells me that local variable task barrier is never disposed. Well, why it should be disposed? Let's pick the declaration. And you can see here that this create barrier method is marked with this must dispose resource annotation, which was introduced quite recently in ReSharper annotations. And actually, even the XML documentation for this method tells that I should use this method with using construct. And of course, ReSharper is helpful, and I can convert it either to using declaration or to using statement. Okay. But now, I actually like to select this part and extract it to a separate local function. And you can see that we have updated our UI for this refactoring. And now I can easily choose the scope, the location for the local function. Yeah. And I think I prefer it to be in the end. And what's more, ReSharper leverages AI capabilities, and ReSharper AI suggests me names this extract method, which is also cool. So let's name it process highlighting file. All right. Yeah, of course, we can convert it to replace it with method group. Yeah, but let's get back to our presentation. But ReSharper today isn't just a Visual Studio extension. It powers a range of JetBrains products as well. Rider is built on the foundation of ReSharper and IntelliJ platform. So it combines smartness of ReSharper with the incredibly rich and robust IntelliJ platform. And it results in the most powerful experience in a cross-platform IDE. ReSharper C++ in its turn powers C-Line Nova, the C++ language engine for the C-Line IDE. And switching to this new engine has improved the IDE's performance and accuracy of features, so that recently it has become the default engine. Next is Kodana. For a long time, if you wanted to run ReSharper's code analysis outside of an IDE on your CI/CD, your only option was to use the inspect code tool from ReSharper command line tools. But now with Kodana, you can easily integrate with any CI/CD tool. You can generate comprehensive reports. You can analyze code coverage. You can detect vulnerabilities and run third-party license checks. And Kodana can even automatically apply fixes for found problems. Sounds really cool. And finally, ReSharper is the code engine behind C# support in Fleet, which is currently in public preview. In case you missed it, Fleet is a modern code editor, but with the twist that you can turn it into more like IDE. And it's modern, and it includes AI assistant, and it has been developed with collaborative experiences right from the first day. And I have to say that throughout the development of all the products that I have mentioned, our .NET tools have been absolutely essential. They play a critical role in optimizing performance. They help us identify bottlenecks, eliminate memory leaks, and ensure quality. I actually can't imagine working without them. I recently came out with this analogy that these tools are analogy with health and performance of humans. So in order to stay healthy and perform at the netlet, you should actually do some lifestyle interventions. You don't need you don't want to wait for symptoms to arise. No, you want to prevent it, because when symptoms arise, it can be too late to fix your health. And what you should do, ideally, you should do regular checkups. So, and with program development, you should do your checkups with profilers. They should be absolutely critical part of your development. Um, Now let me switch to Writer, because I want to show you something. So here I have this little sample code. Yeah, and ReSharper is connected to this database. Yeah, and we have this amazing database experience. I can explore data tables. Yeah, and if I scroll down, yeah, I even have this SQL syntax highlighting inside of my C# strings, which is also cool. And we have it because IntelliJ platform speaks many languages. And I can actually have this language injection for every possible language, because IntelliJ platform supports also many languages, right? And I can have all these languages inside my C# strings. But today I actually wanted to show you something else. So let me run this up. Yeah, so waiting. And you can see that I have this integrated profiling tools right inside of the writer. So I have this CPU and memory view. and my application is running. Let's wait until it ends. Okay, executes. Okay, done. Yeah, and what we see here, so we see here that actually while running our app, we had dynamic program analysis running as well. And I can, yeah, and it highlights some problems. And it actually found some database issues and memory issues. So I can navigate here and it tells me that, yeah, this command executed 5 times and total execution time was 3 seconds. Also, I had this method which opened many database connections. And here as well, I have these SQL connection leak because I didn't specify this close connection flag. Yeah. What else? Yeah, I can see the actual SQL queries that resulted in this long or time-consuming or memory-consuming work. And yeah, and I think it's really helpful, and you don't need to actually run your profiler separately, and it's just part of your work. And continue this analogy that I made. So DPA, dynamic program analysis, is like a continuous glucose monitor. So you don't have to go to some institution and have your blood tests done. You just have it running constantly. So now let me get back to the presentation. So now I would like to shift the focus and talk about ReSharper evolution from developer's perspective. And as a developer, of course, I'm interested in code. And I have a little question for you. So, how much do you think our code base has grown over the past 20 years? And please estimate only C# lines of code. So you should be able to see the poll. I don't know. Does it work? Okay, awesome. So uh, let me continue and I will tell you the right answer. So I was curious about the code. So I took the oldest code base that I could find and ran this clock program. And here's what I got. So I excluded some XML files and other less relevant file types. And you can see that ReSharper was written in C#. It used MSBuild and Lexers for generated from .lex files. Now, I did the same with today's code base, and you can see that it includes files in many different languages, though I applied some filtering again. And here's why. This code base includes not only ReSharper sources, but also the sources of writer, .trace, .memory, .cover, .peak, everything that I covered before. And it even includes selected official plugins, such as, for instance, F# support plugin. And including plugins in the repo has actually been a quality of life improvement, especially for the developers working on those plugins, because we used to break APIs quite often. Yeah. Um, you can see that most of the code is still written in C#. Um, the C and C++ parts mostly come from the native parts of our profilers, but also from test data of ReSharper C++. And yes, we have Visual Basic. Our support for Visual Basic is written in Visual Basic. And of course, we use Kotlin to develop Writer's frontend. But actually, it's not even the whole today's code base. Very recently, during the last New Year's holidays, .NET sources were integrated into IntelliJ repo. So now we're part of the big mod repo, which is a huge deal. Yeah. So now the answer to the poll. Yeah. So comparing old code base and what we have now, we've grown 13 times, which is quite remarkable. We have now, well, it's 8 million lines of C# code. Oh, and by the way, we developed many projects as open source, including F# language support, plugins for Unity and Godot game engines, Aspire, Entity Framework support, and more. And we welcome your contributions. Now you may wonder, how do we deal with that amount of code? And here is the answer. So please welcome BBS CMD, our build system tool. So we used to have a GUI app written in WPF, but we've recently switched entirely to this console app, which is of course cross-platform. And I'd like to say kudos to Andrea Kinshin for helping us retire the old tool. And it's very straightforward. You just select components that are relevant to you from this tree on the right. And then you press this prepare working copy, and you are done. So this tool generates solution for you. And when you are done with developing and want to install your binaries into Visual Studio, you just press local install, and that's it. Very convenient. We host our code in Space Code and run our builds on TeamCity, but we also use some additional internal tooling, which has been evolved over the years as well. For instance, we have a tool called Patronus, which allows us to safely merge our branches after passing thousands of tests. Another tool is called Asgard, which displays different build and performance metrics. And of course, very important part of our internal tooling is performance testing infrastructure. And it prevents merging of branches with degradations. Andrea Kinshin is the guy, the methodologist behind it all. The next thing I want to highlight is the .NET SDK that we use. So as you probably know, the main Visual Studio process runs on the classic .NET framework, which means that ReSharper is also constrained to use it. Rider, on the other hand, runs on the latest modern .NET, currently .NET 8, and enjoying all the performance benefits. However, since lots of code is shared between products, we use a custom SDK with reference assemblies that result from the intersection between .NET Framework and .NET and modern .NET. This is kind of sad because I can't write in modern .NET myself, but I hope we will overcome these limitations in the future by moving more stuff out of process. And meanwhile, in order to use modern C# features, we use various schemes like we declare different classes like system init, system range, different attributes needed for compilation of init only, required properties, interpolated string handlers, etc., etc. Another important technology that we use extensively in our code base is lifetimes. As the name suggests, lifetimes are associated with a kind of specific scope of work. And they have dual purpose. So they function like an inverted indisposable and allow us to execute a piece of work when lifetime expires, which makes them perfect for implementing reactive programming. So as you can see on the slide, we extensively use like signals, which you can advise to handle events, or we can subscribe to and handle every new value of observable properties. Yeah, and the second purpose of lifetimes is that they also behave like cancellation tokens, allowing us to start concurrent tasks. And what is important that Dmitry Ivanov, who designed it, designed them in a way that allowed us to avoid common pitfalls that you can fall into when you use the BCL, the standard library. So also you can see that in ReSharper we have a set of like predefined schedulers to run some activities on either on background or main threads. The next topic I want to cover is UI. So if you used both ReSharper and Writer, you probably noticed that many features such as refactorings have almost identical user interfaces. But despite that, ReSharper living in the .NET world inside Visual Studio, while Writer's frontend runs on the JVM within the IntelliJ platform. So do we implement every dialog twice? Well, when Writer first started, that was actually the case. So many things were re-implemented in Swing, the UI framework used by IntelliJ. However, after some time, Alisa Afonina, who was responsible for refactorings at the time, decided to put an end to this and implemented the so-called B controls, back-end controls. So B controls, they represent UI models, which are serializable because they need to be sent over the writer protocol from backend to frontend process. And these models can have multiple view implementations. So for instance, one in WPF for ReSharper and another in Swing for Writer. And with a set of standard B controls, it became possible to compose any UI that automatically works for both products. By the way, so when implementing the UI for the convert to global using refactoring that you can see on the slide, I decided to create custom B control for these bars, these horizontal bars. Yeah. And while I felt quite confident implementing the WPF view, I had no prior experience whatsoever with Swing UI. So at first, I started reading about the layout framework, but after a few attempts, I decided to try and ask AI assistant for help. And you know what? It worked. It worked just perfectly. Finally, finally, my favorite topic, PSI. So if you haven't heard this term before, it stands for Program Structure Interface. So this is our code model, the engine that drives all of ReSharper intelligent features. So PSI provides a language agnostic framework for building abstract syntax trees and semantic models for any language. Yeah, it's agnostic. So everything in ReSharper, so every language supported by ReSharper, C Sharp, Visual Basic, XML, HTML, CSS, XAML, in Razor, which is a quite difficult mixture of many languages. Every one of them is supported with PSI. Um, but but back in 2014, when ReSharper was 10 years old, Microsoft introduced Roslin, the new .NET compiler platform with code analysis APIs for C Sharp and Visual Basic. And immediately, ReSharper was bombarded with questions about the possibility of switching to it. Sergey Shkredov and Alexander Shvedov weighed all the pros and cons and ultimately decided to stick with PSI. And I should say that we have absolutely no regrets about this decision. So the first reason why was that rewriting something that had been in development for 10 years would take in just enormous amount of work. And we preferred to focus on adding new functionality and optimizing existing features rather than spending years and years implementing what we already had. And the second reason was architectural, because many things that ReSharper does cannot be supported by Roslin or would be highly inefficient. And finally, Roslin covers exactly two languages, C Sharp and Visual Basic. And as I mentioned before, ReSharper is based on the multilingual infrastructure. So now let's talk about C Sharp support. Yeah, only about C Sharp support and not VB support, because C Sharp and VB, they used to co-evolve, but recently all the efforts are concentrated only on C Sharp support, which I think is good. So I joined the team in 2016 and have been working on C Sharp support since version 7.0. And C Sharp 13, which is currently in development. It's 10th language version for me. And every year we have a new release, though once Roslin experimented with minor versions, and which gave us C Sharp 7.1, 7.2, and 7.3. Like many people think that Roslin team should stop developing C Sharp because every year is too much, and we have too many features and language becomes too complicated. While I actually think that I really I can't wait for these new extensions and extension everything and for discriminated unions. Um, but I also see that um, many of the uh, things in language can be expressed in using different syntax constructs. You can implement the same thing in multiple ways, and I don't think that it's very good. Yeah, uh, but also from our perspective, I think that our small team is doing quite well with C# support. We not only manage to provide solid basic support, so you don't usually see false compiler errors from us, but we also cover each new version with features that kind of stay true to the spirit of ReSharper and that you will always support it. We give you relevant code fixes and actions, and uh, you know, ReSharper is known for its help with learning new features. But we also face a number of challenges. For instance, the compiler doesn't always implement new features strictly under the language version flags. So that's why we have to consider not only the language version that you have in your project, but also the version of the compiler which builds your project, which is kind of usually you don't think about this stuff. The next challenge is that supporting the language feature can sometimes feel like a chasing a moving target. For instance, the design of ref safety rules, it was changed 3 times in just a few weeks before the release. And Andrei Dyatlov, who implemented support on our side, yeah, he re-implemented it also 3 times, and it was like, oh my god, I need to re-implement it again and again. Why can't just they do it from the first time? But I have tremendous respect to the compiler team, but yeah, making changes right before the release is kind of not very good, I think. Another aspect that we have to consider is the IDE friendliness of language features. Some features can actually make the IDE slower. So, for instance, the ability to omit the type name with the target type new is great, no question about it. But the language allows it even when the type name is not evident, when the type is not evident from the context. Actually, uh, the type name can even be not mentioned at all in the current file. And this means that the find usages feature, when invoked on the constructor, can no longer narrow its search by type name. And it has to scan more files just because hypothetically a constructor could be used by such a target type new construct. And I know about this problem very well because it affected our users, and I was the one fixing the performance issue. That also, I want to say that some language features are very technically demanding. For instance, nullable reference types were extremely difficult to retrofit into the language. But given our extensive expertise and tests for nullability analysis, the compiler essentially got a double check-in from us. I believe that Andrei Dyatlov alone filed hundreds of bugs. And in other words, I think that our work directly contributes to improving the quality of the compiler itself. Yeah. Okay. So we've covered the internals. And I almost finished my talk. By the way, at first, I thought about showing you some tips and tricks, but a couple weeks ago, Matt Ellis did this amazing session. So please watch it. So please watch it because I have no doubts you will learn something new, or you will. It will remind you about some features that you don't use. But before wrapping up, I'd like to say a couple more things. So in this limited time, I've tried to show you how much ReSharper has evolved over the past 20 years. From a Visual Studio extension, it has grown into the powerful engine that drives a range of products. And I also unveiled some of the ReSharper internals and shown you the changes happening under the hood. I hope that you found it interesting. And I also believe that ReSharper will continue to develop and will power even more exciting products in the future. I'm sure it will have stronger AI features, yeah, and it will have better integration with IntelliJ, like we already have with Grazia, which gives us this grammar checking and yeah, so other stuff. But I think the next 1 years are sure to be exciting. And I also want to speak to you, our dear users. Oftentimes I see how people use our products and I want to say, please stop. Well, why do you do this all manually? We have all these incredible features for you. And it happens with many people, even with our junior employees, with my teammates, with with you know, bloggers. Yeah. So I watch some Nick Chapsos doing his stream, and no, he's not using this feature. Yeah, but he actually could automate all this stuff. Yeah. So what I want to say that I think that now is the perfect time for some ReSharper seasoning. So uh, master your IDE, learn how to use it more efficiently, learn from your colleagues, explore our blog posts and videos, and then teach others, teach your teammates how to use it, make an impact, and above all, develop with pleasure. That's it. Thank you for your attention.
Thank you very much there, Andre. That's a fantastic talk. A huge amount of really interesting stuff covered there with ReSharper. It's a fantastic tool, and it's brilliant to see how it's evolved over the last 20 years.
Absolutely, really cool talk. Thank you for that. Also, I like that you've been giving a shout out to the developers responsible for various features and upgrades and so on. I know as developer advocates, Matt and I, we often get kudos at the booths and we report them back to the team. But just to give people a little bit of an idea, how big is the team and does everyone work on everything, or how is it structured?
Um, well, just recently we had some changes in the structure. So, for instance, our team that works on C# support on this PSI, it used to be under ReSharper. Now it's kind of separate team, and it includes, I think, um, 10 members. Yeah. And ReSharper team itself, I don't know how big it is. I don't remember.
It's quite complicated, isn't it? Because
Mm.
talking about the way that ReSharper is an engine to be used in different products, it does feel like people work on different areas all the time. So it's somebody who I thought was a core ReSharper developer is doing something on Rider now, or they're working on dot memory. So it's nice that I like the fact, sort of sitting outside the team, that people can move around and work on different features.
Yeah, yeah. And sometimes you just do something that you don't expect to do. So
Mhm.
while I was implementing support for raw strings back in C# 10, so I started supporting more and more features, and I came to language injections. Yeah, and I had to support it in ReSharper. Okay, I did it. I know how to do it. But then, yeah, I thought that it would be cool to have extended language injection support in Rider. And I don't know how, but I ended up writing Kotlin. Yeah, but it was cool.
Well, exactly. If you're developing on, building a ReSharper, which is a Visual Studio plugin, of course you're going to write Kotlin code. It makes perfect sense. But it's nice like that. And interestingly, I think injected strings are a great feature of. It's one of those features which is really interesting and surprising, allowing you to have a string literal which provides embedded ReSharper support and everything, which is really cool.
Yeah,
But
you
what
can
what
even embed C# into C#.
what
Yeah, yeah, you can have C# code highlighting right inside of the C# string.
All
You
right.
you you would you don't have code completion and advanced features, but at least you have code highlighting, and it's actually quite cool to have this code highlighting if you develop things like source generators.
Okay, that makes sense. You broke my head for a minute there. I couldn't think why you would want to do it, but that's a great idea. If you're doing source generators, you're going to have to write out strings of C sharp, and so it makes sense to get code highlighting and all the features there.
Yeah.
Um,
One of
I
the things
was
I think is really cool with those string injections is also that when you use them in Rider, for example, it is ReSharper handling all of the C# code there, but it might be that when you connect to the database that the Rider database provider is adding to that. So it's really front-end Java with back-end ReSharper, combining all those things together.
Yeah, there's a lot of cool things going on under the hood there. What I was going to ask you though was, what is your favorite feature after sort of working with ReSharper for such a long time, developing with ReSharper? What would be your favorite feature, and possibly what would be the one feature you wished everybody would use and they're not?
Um, wow, such complicated questions. I have so many favorite features. Yeah. Uh, I think my favorite is rename. I like to rename stuff. But I think that everybody should start using structural navigation because it's really cool way to navigate through the code and to edit parts of the code.
Could you explain that one a little bit more, actually? Because I did spot that you used it, but that was so quick there. It was,
Um, yeah, maybe I can. Do you see my screen?
yes, your screen's back.
Okay. Yeah. So I press tab and the whole while construct is selected. I press tab again and now I have this condition selected. and I can
Oh,
go
okay. So
through the
sorry. So
code.
just to interrupt there, if you've got the condition selected there, it's then really easy to just replace that condition, isn't it? So that's good. So you can hit tab inside the while to then immediately select the condition
Hmm.
to
Yeah,
replace it, rather than
yeah.
having to kind of go through all the old school, shift left, right, and
Hmm.
whatever just to edit it. Okay, that's cool.
Yeah, yeah. And what is also cool that um, so for instance, if I don't know which example to show, but we extended this feature so that uh, oh, it doesn't work. I have this indenting. Let me navigate here. Yeah, so I pressed delete.
Hmm.
Yeah, let me repeat it again. So I have the whole condition selected, and I select this operand, and then I press delete, and it deletes both the operand and this greater than operator. So it works structurally as well. So we call it structural remove. Yeah.
Yeah, that's really
Um,
cool.
yeah.
Sorry.
Also, yeah. I also sorry for interrupting you. So recently, I've been working on quite huge refactoring, and um, at first, as a developer, you often uh, find usages, and I find myself that uh, first I invoke find usages for this method, then I go upper for the containing stuff and invoke find usages again. But we have an feature which works exactly for this scenario, which is called incoming calls. And it's really, really cool. So I really embrace this feature, and I think I oftentimes I invoke incoming calls just instead of find usages because it's that's what I need at the moment.
I'm a huge fan of incoming calls, actually. That it is. I mean, thank you for giving the shout out to the tips and tricks talk. It's one of the big ones I always talk about as being, really, really, really helpful. We spend a lot of our time reading code, and this is a great way to then sort of see, well, okay, here's a method. Where's it called from? Okay, I like that method. Where's that called from? And you continually do that, and being able to see the tree there is fantastic. The other thing I was
Can
going
I
to say
quickly
is
can I quickly add to that one? Because
yes.
there's another really interesting one that is one of my personal favorites while reading code, and that is the value origin, where you can say, okay, look, I
Yeah.
have this parameter to this method, or I'm using this variable. Like, where is it being set? Where does the value come from? Does it come from a database? Is it being used on a form somewhere?
How could this
Which is
possibly
super
be null?
helpful. Yeah.
Mhm,
Exactly, especially when you're trying to figure out like why can something be null or add nullable annotations and so on. This is really a lifesaver to figure out how is this value even set in the application.
mhm. Yeah, and the other thing, I mean, the structural navigation, I love that as well, and I hadn't even got to covering that in the ReSharper tips and tricks talk. One thing you said towards the end there as well is it's surprising of how much functionality there is in ReSharper. There's a huge amount of stuff, and it really does pay to spend some time and learn some of these things. Rename, definitely. Never use find and replace. Never ever use that. Structural navigation's cool. I always like the expand selection. And moving statements around as well. So you can do a whole lot of stuff um, without having to do cut, copy and paste. It's like never cut, copy and paste. We can do it all for you inside the editor. I always forget when using ReSharper or Rider that we've got all this tooling that helps you with editing. We kind of got loads of things. It's obvious that we've got things for inspections, for refactorings, for quick fixes, but we can help you with just plain old editing as well. Anyway, I'm starting to go and do my session.
Yeah,
I can do another
again,
question.
another shout out, I would say watch Matt's session, because there is probably always something that you will learn, even if you have been using ReSharper Writer for many years. I always love to see colleagues present on it, because there's always like a small thing where you go like, huh, I didn't know that we could do this. So definitely recommend
I
it.
learned stuff, preparing for it, and learning stuff with the structural navigation there as well now. And in fact, this is like this when we were talking about being at the booth as a developer advocate and what this, and also how you learn ReSharper. When we first started, I started back on ReSharper 4, and the moment was the jaw dropping, sitting next to somebody and going, "Look, how did you do that?" And then we'd trade tips like this. It's ridiculous.
Yep. Given you are a ReSharper developer and working on the code base and so on, I think you have the code base open. I can imagine in a code base that is 20 years old, there's probably a couple of things that you want to keep buried. But I guess there's also a couple of things that you might want to highlight. So what is one of the cool things that we have in the code base that you think, well, this is clever. This is something really nice to show to people.
Oh, yeah. Wow.
I mean, looking at it, I know from when I first opened up the ReSharper code base, there was this really clever way of overloading file paths on strings, so that essentially you could combine strings and add the division operator between two strings, and then you would generate a path that had the right forward slash or backward slash depending on your operating system. And that was one for me where I was like, yeah, this is clever, this is nice.
Yeah, I think so. I mentioned B controls, but I haven't showed you any code. So I can show you how it works, just if you are curious. So yeah, so I have this page and I have this get page content method overridden. And so it's really easy to work with our framework. So at first I call this get grid methods. So I get grid and then I put stuff onto it. And if I need this file name input, I can easily initialize it, and I can tell that whenever there is a new value that the user provided, I need to update my data model. Also, I can set up some validation. I can tell that I only want to have such extensions here. And I can even say that I want to have this file completion right inside of this edit input. Yeah.
And so all of that, the whole point of this is to be able to then abstract away the user interface toolkit. So you would get a text control with all those things in WPF, but then if this is when this is hosted in Rider, it would then have the same functionality in Swing.
Yeah. Yeah.
That's cool.
Yeah, that's super cool. So Ali Safwanian did such an amazing job because, writing Swing from scratch is not an easy job.
No,
No,
it's
and
not.
writing UI in general is not super pleasant task. But having an ability just to use a set of predefined controls is just a time saver.
But then there's no XAML or anything here, so there's nothing sort of describing
Yeah,
the UI and the layout there. Is everything just kind of placed on a grid?
yeah. In this case, everything is placed on the grid. I think so. Here I'm defining some columns, and because I have a tree, I also have. I said that I have this multi-selection. Also, I set up some stretching and alignment, etc., etc. Yeah, so everything is abstract, but when it comes to showing UI, there is a component which transforms this model to an actual WPF or Swing UI controls. Yeah.
Mhm. And I guess it makes sense to just keep it quite simple. Most dialogues are actually just a grid of controls, isn't it? There's a text field, like 3 or 4 text fields down here, label text field, and that. So actually, a grid layout works nicely for that. And as long as you have your sort of styling set up around that, it should work quite nicely, shouldn't it?
Mhm.
That makes well, I mean, it does work quite nicely. We see it in action. This is good.
Yeah.
That's a nice system. I like that.
Yeah, we actually, I don't know how much time we have because I can continue talking and talking about ReSharper. We have really cool thing which is called zones. So this is
Yeah.
yeah, this is kind of it both dependency management tool because it defines that I can't directly reference these classes from this namespace. And because here is, I like this namespace should be responsible only for C# and not for UI. Yeah. Um, but also zones they allow us to develop many products from single code base because your code becomes associated with different zones, and you can instantiate some of the zones. We actually tell activate. Yeah, so you can activate some zones and don't activate others. Yeah.
And
So
when you say activate, this is we've got a component container, haven't we? So we don't tend to new up our own objects. Things
mhm,
get
yeah.
created for us.
Yes. Yes, we have
And
our own component container implementation, which is quite advanced. And as I mentioned, Nikita Popov and Ilya Usov did a tremendous work to optimize it because part of the problem with startup was that many components were initialized during the startup. And what they did, they actually told that, okay, this component, they can be delayed, they can be instantiated on demand. Yeah, but it was really hard to categorize components, to tell apart that this component is safe to initialize on background thread and this component is not.
and you've got to take into consideration dependencies as well. It's
Yeah,
yeah, that's not a job I'd like to do.
I'm really happy you are taking care of all this. Yes.
Yeah.
Cool. Do we have time for one more question? I think we have.
I think we could squeeze another one in. Yes.
Yeah.
Martin, you going to
Yeah.
ask it?
Someone in the comments was asking about this task barrier class that they saw in the ReSharper code base on screen. Why do we even have our own threading and task handling methods in there?
You mean in my example or in ReSharper code base?
Yeah, well, in your example, but also in the ReSharper code base. Yeah.
Yeah. Why do the classes exist?
So yeah, task barrier, like as name suggests. So I can spin up many threads, and I want to wait until all of them are finished, and that's the work for that's the exact definition for a barrier, task barrier.
Okay, and we've just built our own library of things rather than using the .NET standard library.
Oh yeah, yeah, we do. I mentioned in my talk that BCL library has many pitfalls, like especially with tasks. Yeah, because some of the things that should be explicit, like uh, schedulers, they are implicit. You can omit them, and you don't know on which scheduler your code works. But the things that can be implicit, like cancellation tokens, you should pass every year through every method and local function, and you should use exactly this cancellation token if you want to instantiate and throw operation canceled exception. So only then your task will be considered canceled. So our implementation kind of fixes all of this, and Dmitry Ivanov, he no longer works at JetBrains, but he left really great legacy. Yeah.
Yeah, it's nice that it kind of helps to
Yeah.
keep you a little bit safer then,
Yeah.
which is
We
good.
also we have like lots of synchronization and threading primitives. We have channels. We have actors. Really
Wow,
cool stuff. Yeah.
that's nice. I need to dive back into the code base. It's been too long. This is cool. Okay, I think we'd better wrap up. Andrew, thank you very much for a fascinating talk and conversation there. It's been a brilliant session, and congratulations on 20 years of ReSharper.
Yeah. Congratulations.
Thank you.